the bud stage, you can see the epithelial structures going inside the cellular myxomatous connective tissue, which is a ectomesenchyme over there. During the bud stage, dental lamina goes into the mesenchyme at 10 different points. It is represented by the first epithelial incursion into the ectomesenchyme, and bud stage is characterized by round, localized growth of epithelium surrounded by proliferating mesenchymal cells, which are packed with beneath around the epithelial buds. So this is your bud stage. Then it is surrounded by ectomesenchyme, and the area of condensation immediately subject to the enamel organ is dental papilla. After bud stage, you get cap stage. In the cap stage, you will get the cell become a little bit more columnar, more cellular, and the enamel organ will get established. That the tooth continues to proliferate, it does not expand uniformly into larger sphere, and instead unequal growth in the different parts of the tooth bud leads to the cap stage, which is characterized by shallow invasion on the deep surface of the bud. So in case of cap stage, you will get enamel organ, which is epithelial structure, and underneath it will cover an ectomesenchymal structure, which is called as dental papilla. And this dental papilla finally gets converted into dental pulp, while enamel organ gets converted into enamel and earthy epithelial of root sheath, which will give rise to the roots as such. So that's the enamel organ. Now many times in the exam they'll ask you describe structure. So if the cap stage comes, you have to talk about enamel knot, enamel niche, and enamel cord also. And the dental follicle, so there are three parts of cap stage. One is enamel organ, dental papilla, and the whole structure is surrounded by dental follicle or sac. So enamel organ, dental papilla, and dental sac forms cap stage. So there are temporary structures in case of cap stage, namely enamel knot, enamel cord, and enamel niche. So what is enamel knot? In the center you can see it's a densely packed accumulation of the cells projecting from the inner enamel epithelium into the dental papilla, and exact role is not known. But nowadays they say that enamel knot is responsible for which tooth is going to form, whether it's an incisor, premolar, molar, etc. So now enamel knot role has been established. Enamel knots are clusters of non-dividing epithelial cells visible in section of the molar, usually in the molar cap stage. It is first noted by expression of the P21 gene. If they ask you to score more, you have to talk about genetic aspect, and you just remember few molecular markers like BMP2. BMP means bone morphogenic protein. FGF means fibroblast growth factor. Okay. Now enamel cord is nothing but a pattern of enamel knot that extend between the inner and the outer dental enamel epithelium is called as enamel cord. Enamel niche is nothing but it is an artifact produced during sectioning of the tissue, and it occurs because the enamel organ is a sheet of proliferating cells rather than a single strand, and contains a concavity filled with ectomesenchyme. In this section you can see there is a central connective tissue core which is labeled as enamel niche, and it is produced because of sectioning. After cap stage we get bell stage, and in the bell stage it becomes more organized. So the bell stage you will get dental lamina, outer dental epithelium, inner dental epithelium, dental papilla, stellate reticulum, cervical loop. Now remember, in the cap stage, you won't have so much of cellular structures. The morphodifferentiation will start taking place. The histodifferentiation has already taken place over there. So continued growth leads to bell stage from cap stage, where the enamel organ resembles the bell with deepening of the epithelium over dental papilla. So now after this stage, you will get morphodifferentiation, means your inner epithelium will get converted into ameloblasts and odontoblasts. And because of that, you will get morphodifferentiation, that your crown will start forming. Now many times, if you read 10 Kate, he will not call dental epithelium. It will call you as a inner enamel epithelium. Because according to them, enamel organ give rise to only enamel as such. So next is cervical loop. What is cervical loop? Area where the inner and the outer dental epithelium meet at the rim of the enamel organ, it is called as cervical root. And this point is where the cells will continue to divide in the tooth crown attains in full size, and which after crown formation will give rise to epithelium for root formation, and it is called as zone of reflection. So cervical loop is nothing but where the inner and the outer enamel epithelium meets is called as cervical loop. And in case of Bell stage, you will get one more epithelial structure called as Stratum Intermedium. In Cap stage, you got inner enamel epithelium, Stellate Reticulum, and outer enamel epithelium. But in case of Bell stage, you have inner enamel epithelium, outer enamel epithelium, Stratum Intermedium, and Stellate Reticulum. In Cap stage, there are only three structures, three cell layer structures, while in case of Bell stage, it is made up of 4 layer structure: inner enamel epithelium, outer enamel epithelium, Stratum Intermedium, and Stellate Reticulum. So, inner epithelium, what is it? It's a short columnar cell bordering the dental papilla, and this will ultimately become ameloblasts, the cells responsible for enamel. Right now, they are not very tall. In case of ameloblast, you will get tall columnar cell with reversal of polarity. So what does reversal of polarity? When the nucleus moves away from the basement membrane, is called as reversal of polarity. So if you want to show ameloblast, always draw nucleus at the top of the cell, that is away from the basement membrane, away from the dental papilla towards stellate reticulum. Next is just above inner enamel epithelium, you will get stratum intermedium. Now these are flat cells, and this is very, very important. In the exam, they will ask you what is the function of stratum intermedium. Now remember that stratum intermedium is very rich in high alkaline phosphatase activity. Now this alkaline phosphatase activity is very, very important for calcification. Remember, wherever alkaline phosphatase activity is there, formation occurs, like for the bone formation, for the dentin formation, for the enamel formation, any hard tissue formation, you need alkaline phosphatase activity. While for resorption activity, you need acid phosphatase activity over there. And they assist inner enamel epithelium, that is ameloblast, to form enamel over there. Stellate reticulum, as everyone knows, it is very important that they are stellate shaped, star-shaped cells. It is very rich in GAGs. GAGs means glycosaminoglycans. And one of the most important function of stellate reticulum is, you can say act as a function as a shock absorber. Okay, remember, it's rich in protoglycans, GAGs. At the same time, it's responsible for shock absorber. Next is dental papilla. Before the inner dental epithelium begins to produce enamel, the peripheral cells of the mesenchymal dental papilla differentiate into odontoblast. Remember one thing, although enamel is on the surface of the tooth, first structure which you come across, supported by dentine, but in reality, dentine always forms first. Remember that much. That if they ask in the exam, which tissue forms first, you should say dentine forms before enamel, or enamel forms after dentine. And the basement membrane that separates the enamel organ from the dental papilla is called as membrana preformativa. Remember, they can ask you, what is membrana preformativa? Then membrana preformativa is nothing but a basement membrane separating enamel organ from the dental papilla, and that is nothing but the future dentino-enamel junction. So dentino-enamel junction is decided by membrana preformativa. crown pattern starts forming during Bell stage. After Bell stage, you get advanced Bell stage. Now here only one difference you remember. Then in the Bell stage, you label dental papilla. But now you will label dental papilla as dental pulp because dentin is already formed. Enamel has already started forming. So in case of advanced Bell stage, you will not get Stellate Reticulum or Stratum Intermedium. You will get dental papilla, dentin, enamel space, and maybe covering reduced enamel epithelium. And in case of advanced Bell stage, you can say morphodifferentiation is taken place. Till Bell stage, in the cap stage and the bud stage, there is a proliferation. While in case of Bell stage, you got histodifferentiation. The cells start differentiating. Histo means cells start differentiating. In morphodifferentiation, they start forming the structures what they are supposed to form. So in case of morphodifferentiation, ameloblast, inner enamel epithelium got converted into ameloblast, odontoblast, and dental pulp. Ameloblast give rise to enamel, odontoblast give rise to dentin, and dentin papilla becomes dental pulp. And you cannot see enamel in this section because these are the decalcified sections. Remember, in case of decalcified sections, you cannot see highly calcified enamel because it gets dissolved during decalcification procedure. If you want to see any hard structure, then you're supposed to see under ground section. Remember, so if you take to see enamel microstructures, then it is better to see it under ground sections. In the exam, they'll ask you, you can see enamel better in, then you say same better in ground section. Dentin can be seen in both, but if you want to study pulp and periodontal ligament, you cannot study it in ground section. It is seen only in decalcified section. The advanced Bell stage, as I told you, you got ameloblast, odontoblast, dentin, enamel, and dental pulp. Because of this, the stellate reticulum which is there, they starts collapsing. At the same time, you will get, there will be a folding of the outer enamel epithelium or the enamel organ because the blood supply from the periphery will start giving supply to the enamel organ.